Welcome back to the sim. Here we are on the ground at the lovely Ottawa Flying Club. This is the Roman design scenery and it's pretty cool. We're back in it, going up with the Autopilot we built using an Arduino and 3D printing. So bringing it back in, we've got ourselves on the ground with the Autopilot. Now we've done the coding, we've done the building, but how do we link it into the sim? So what we want to do next is we want to head over to Device Manager. Now you should have already been able to pick up this COM port from programming your Arduino, but let's say you're like me and you programmed it on another computer. You've now plugged it into your sim. It could be on a different COM port. Now my Arduino Leonardo, which is the GPS 530, that's in COM 4. My GTN 750 from Real Sim Gear, which is built on an Omega, is in COM 5, and so Windows automatically added the Uno into COM 6. So we know it's on COM 6, so let's go ahead and write that down. So looking over into SPAD.next, we're going to head into our settings. But before that, we are on 9.10.14. However, Arduino support should be valid even in the release edition .0. But if you're not sure, don't forget, you just go into settings, go into application settings, go into expert, and here's where you update to the alpha channel. Now using default aircraft like this one here, we don't need the LVAR bridge. However, once we get later on in the video when we go into the CJ4 or we head into the CRJ, since those are now using H events and LVARs, we need to be running the LVAR bridge. So don't forget, after doing your upgrade to alpha, head on over here to this video in the link, which will show you how to install the LVAR bridge if you haven't done that already. For our serial devices, we need to head over to Devices. We're going to go into Serial Devices. And first we want to make sure it is enabled. Then we're going to hit the Add New Device. And you can see I've already got mine on COM 6. So effectively you click on it, you pick those available COM ports. And again, that's why we wanted to write it down to know which one it is. And you're going to set the speed to 115 because that's what we programmed the Arduino to open as in the last episode. So we're going to go ahead and we are going to click OK in that. It's going to add the device. After you add the device, you have to close SPAD.next and launch it up again. So let's go ahead and do that. And now that it's launched, we head on over to our panels. And we'll now have our serial devices there. Now right away you don't see any information. However, if you click on the show log, you're going to see all that data flowing in that we programmed. And just like we saw in the programming, the first thing it does is it starts up and it goes ahead and it registers all of those data values into the sim for us. And now we've got our enunciators and it's pinging and ponging. So that's the keep alive. So as you recall, we set it up so that all the events that we send are going to come in to our second VJoy panel. Now, if you haven't set up VJoy, we have a separate video for it, which you can also find in the list of how-to videos. But looking quickly at the VJoy configuration, you can see that the first one, which is the one we use for our cameras inside of Microsoft Flight Sim, the second one I set up to be the device I was going to use with my Arduino. Now I chose to set it up as 32 buttons and no POVs and no axes, hence it only shows up as 32 buttons here inside of SPAD.next. So for every button that we set up, we now can use the buttons here to assign the task. So if you recall, all of the buttons that we have. So it's 1, 2, 3, 4. Technically, I went around this way, but 5, 6, 7, 8. And then the push button on the encoder was button 9. Then we've got the encoder itself with the turns going counterclockwise and clockwise are on 10 and 11. And what's really cool is if you're concerned or trying to remember what it is, coming here with the log, if you remember, we had it so that when we press a button, it will write into the log which button we pressed. And so you can see in one, emulate the VJoy instance number 2, because remember it's 0 based, button 1 pressed. Awesome. So for the buttons, we use our VJoy for Arduino that we've set up. And remember, these VJoys, if you want, you can relabel them. So I changed it to VJoy for Arduino. That way in the side it tells me. So button number 1, since this is our AP button, we've gone ahead. So we added that event, pressed short, and what we did was we added an action, send simulation event, and I simply put in AP, and we get all of our autopilots starting with AP underscore. So we found AP master, and this is a toggle, and that's exactly what we want because the button itself is just a toggle button. And so we're going to use the screen to be our annunciators for whether it's on or off. So we clicked on that, and that was our event. And then we clicked OK. Saved it, and then we moved to button 2. So button 2, we wanted to enable AP panel heading hold. Now, there's a bunch of options for these buttons. So what you'll see is there's AP panel, and then there's just AP. So if we did AP heading hold, this is going to engage heading hold mode. We'll also change the heading bug to the direction that you were flying. So currently, we have it that when we're on heading mode, you can dial up your heading. And now when we press heading and it enables, it didn't change. Had we used heading hold instead, we'll still get the annunciator come on. It'll still enable heading mode and disable it and toggle it. The problem here, though, is it would change your heading bug to match your current heading bug. So you'd enable it, it would change to your current heading, and then you'd have to redial your heading again. Then we came over to the next button, which was our altitude. Same thing. Panel altitude hold. That way it enables the button, but doesn't change the pre-select and go to a heading an altitude capture of where you're at. Approach mode. So we've enabled the autopilot approach mode hold. So because there was no panel approach button, we had to use the mode button. But again, this doesn't change other values. So it behaves in a similar manner and toggles approach mode on and off. So we went ahead and we added the back course hold for the reverse button. Button 6, which is IAS. This uses the flight level change event. So in Microsoft Flight Sim, they went ahead and they used a newer event for flight level change, for toggling it on and off. And this is a panel event. So this is the equivalent of pressing the panel event. So then we've got our nav hold. So this will enable autopilot nav mode. And again, that's going to be dictated by what you've got going on with regards to your CDI. Is it tracking GPS or is it tracking the VOR radials? But that's all based on your CDI anyway. And finally, button number 8. This was the course button, which made no sense. Again, it would have been way cooler if it said FD Flight Director, but that was what printed out from the files we found, and thus I just reprogrammed it to be my Flight Director button. So we can go ahead and toggle the Flight Director on and off. When we come to the encoder, this is where we get to track information. Here, with the encoder push button, which is on button 9, you'll see that we added an event, but only when the rotary switch is in VS mode or selector is set to 2. So now that the selector is set to 2, if we press the button, it will enable VS mode for us. And if we press it again, disable the VS mode as well. So to add the condition, we went to add condition, and it asks us to look for the source data. And remember that this was our unique data provider. And so here we've got all of the data that we're serving up from our Arduino. And so we have the Autopilot switch RSelect data. So that's the rotary switch. And we added that data as the condition. And then whenever it equals 2, because we set it that in the first state, it will set this data value to 1. When we switch it to the VS state, it sets the data value to 2. So only when it's in 2 will it send this event. And thus, if we wanted to add more events to it, we could add another event and specify a condition. We come over to the encoder. So here we made button 10 be our counterclockwise or decrementing, and we made 11 our increments. So for button 10, we set up a bunch of events. And the first one, so when the selector is on 1, we are going to decrement the Autopilot altitude variable decrementing. So this is the send simulation event, SimConnect Autopilot altitude variable decrement. And this is what the default Autopilot is using for the altitude selector variable. And then we just did the same thing. We then, copy and pasted, changed. So we highlighted this guy. We just simply went copy this one event. We then went paste, pasted it in. We clicked on it. We changed this value to when it's 2. And then we came in here and we said for this, it's VS. So we went AP, VS, variable, decrement, and we just clicked OK. And so with that, we changed that variable. And then also what instruction it would send. So we'll delete it so we don't have it twice. So then we copied and pasted, we changed it to the condition to 3, and now we did our speed variable decrease. Then we did 4, our heading bug decrease. We did 5, and that was our VOR1 OBS or OBI decrement. So that's going to adjust our course for when we're doing a VOR or ILS approach for VOR1. Then we came over to button 11, and we went ahead and we did all the same thing, but for incrementing. So it would have been just as easy to copy all events, come over to this button, paste all, and one by one come through and change them from the decrement to the increment, decrement, increment, decrement, increment. So with that, now what we've got is the ability to remap those buttons on a plane by plane basis. So every time we load a different profile, so here I'm in my Microsoft SR22 G1000 profile. But if I was to jump to my CJ4 profile, SPAD.neXT sees that we changed our plane, it will change it. But if we go to the CJ4, just real quickly to look at this example, you're going to see that just by loading it, right, when we go to our Arduino info, now what we're going to have is the events are different. So here we're going to be sending the H events, which is where we need the LVAR bridge to send these events. And you'll see that with the encoder, we're now controlling the increment variables. And some of these are the same used with the CJ4, which is really cool. But again, you're going to find that the H events are different. Now, when we go and we hop on over to doing our enunciators, so the on-screen enunciation, these values will also be driven differently. So now that we've created this, and to make it available for everybody else, I'm going to go ahead and I'm going to publish, and I'm going to select the complete device, and I'm going to leave it for all aircraft. And that's just so that anybody searching is going to find this pop up as a VJoy device. Because again, you don't have to uncheck the box manually. So we'll go ahead and we'll submit that, and all aircrafts, complete device. Yes, we're good. Submit. So it's now published that successfully. So if I was coming in and I needed to grab this and bring it in to another profile. So real quickly, we'll just use the great example. So now I load up my Cessna 172 G1000. Of course, I have not yet mapped my VJoy for Arduino, right? But I know that all these parameters are going to apply because they're using the same thing. Or it at least gives me that base to start from. So I'm going to click on a button like I did, and I'm going to go to Online Snippets. And now I'm going to look for virtual joystick devices. Of course, it pops up right away. So there it is. But I could go to virtual joystick devices. I could go to complete device. And I see with a complete device, I've got the VJoy. Now, if this one doesn't show up for you, right here, there is a show all devices. And this can come in handy just in case for some reason the devices show up differently. As an example, you'll see it with the honeycomb yolks. You'll end up with a bunch, or BB box interfaces. They can register as different devices. So it's just helpful to be able to see it. But again, here you'll see that it looks like they're showing up pretty much as the same devices. So that's pretty good. So here's one labeled, it, and you'll see I've got my working title one, it published up under this, whereas for some reason, this one published up under here. So we're going to go ahead, grab complete device, click on that. We're going to click OK. And it's going to ask us, of course, do you want to replace all events? I can't move the thing. You just say yes. Sorry, I couldn't bring it on screen. And of course, now all those events come along with that profile. So I'm going to save that to that profile. So the second part that we're working with is going to be the enunciators and how we make the panel enunciation happen. To do that, we're going to leverage the script panel to tie all these variables together. And again, just like using the VJoy, the script panel is what allows us to make it generic on the serial protocol and not have to change out our firmware. So the first thing we wanted to do was link data variable, as you may recall. So real quick, let's go to add-ons. Let's go to the data monitor. and we're going to add data. And simply put, we're going to hop on over to our Arduino, and we're just going to grab all of these. So first we'll put in our Autopilot modes so that all of those will show up in, and I'm doing this because I want stuff in a specific order. Now we're going to go back in, and then we have our other data values, which we never actually mapped. So let's do that. And then I want all of these. Plus we'll take the transponder code, and then we'll go ahead and we'll grab the data value and our R cell. So our rotary selector. Now I'm going to go ahead and I'm going to undock this. And that way we can have it on screen and work with the data. So now in our script panel, we start to understand what we're trying to do, right? That data value, so that window, when you remember going back and looking at the callback and how the data value was going to be deleting and auto updating based on the callback or the data values changing. So to do that, we needed to take the script panel and use it to take data from the sim that we want and reapply it to this value or this variable. Now originally when I was doing it, the thought was that all of those data values, altitude, course, heading, IAS, and vertical speed, I was going to have to build data to track all those at all times, to update those, and then I would change this path based on that and rewrite the data to these values. Instead, what I figured out, which would work way better, was to make this data, as we talked about in the previous episode, update as one solid piece of data, and we would use the script panel to change when we were updating that data value. So we called it data V. So that whole window down here, we're calling the data value. Well, you'll see that the data that we are updating was the selector, right? So we're constantly updating when we turn the selector, what mode the selector is in, updating that value. So we came here into the script panel. We clicked on, a script plate. I chose the upper right. I gave it a name just by changing the label. So I came to change label, Autopilot data. Submit. Sure. Autopilot data is what this one is, and that one's autopilot mode. So we came to the first one and we created a condition, right? So we clicked on condition. The first condition was check that the rotary switch equals 1. Excellent. Now this next condition, so that it would constantly run, as long as it's switch 1 and autopilot variable is greater than -1000. So it checks that the switch is 1 and it does this. That way it's actually constantly running the update, right? Otherwise you'd change the value, you'd have to switch back into switch 1 to get it to trigger the update. So I did this as a means to constantly check the condition. So these two are met, and by those two being met, what we then did was we set the data. So that's a add condition, change data value, and it'll automatically open up to there. And what we picked was that the target data we wanted to change was our Autopilot APV data V. So we went to our provider, we went to this guy, and we selected it as the data that we wanted to change. We wanted the operation to be a set, so it sets it, but instead of giving a value, we chose value of, which allowed us to go and find the data provider, which was Autopilot altitude lock. And so we just went to SimConnect. I went for Autopilot, and we went to Autopilot, altitude, lock, and the variable, right? And so we got our altitude lock variable, and then we confirmed. And so now it's constantly going to drive and update that. So when we're on the altitude and we turn that knob, it's automatically going to come on our screen. And of course, if we switch to VS, we see our VS rate. And if we switch back, it instantly updates. Copied, copy this event, and then we pasted it, and then we edited it. So when we edited it, we came in, we changed this to 2. We then changed, now we chose Autopilot vertical hold variable. Now this one I changed to minus 10,000. Obviously minus 1,000 feet is very easy to do. So I changed this to as long as it's greater than minus 10,000. And then we changed this to Autopilot vertical hold variable. So it was on Autopilot altitude VAR. We changed it to vertical hold VAR. So we did the same thing for our airspeed hold. Number 3, as long as our airspeed hold was greater than minus 10, I could have made this minus 100. Basically, it's greater than 0, right? As long as it's greater, well, greater than minus 1 would have been fine. That way, we track it as we spin our knob for our flight level change speed. We added the same thing for heading lock. And again, as long as our heading lock direction does not equal minus 1, because we go 0 to 360 for the heading bug. We followed for course, as long as nav OBS 1, right, does not equal minus 1, again, because it's 0 to 360. And for fun, when you go to 6, we write the transponder code down into it for now. We're doing nothing else with it, but for now we can at least view it. Later on, we will add buttons for changing transponders inside of the encoder. So I'm going to take this and I'm going to copy all events. I'm going to go to this guy and I'm going to paste, and I'm going to change the label individual data. And the purpose for this is we're going to come in and we're going to delete that condition. So we don't care about the rotary switch. But now, instead of targeting this variable, now I want the independent altitude value. So now it'll update just that value. And again, same thing, we're going to come in, we're going to delete that guy, but now we're going to go with our APVSV. And grab this guy, we're going to delete that condition, we're going to grab this, we're going to change this, and we're going to go ahead and we are going to update, oh man, which one was I on? We were on airspeed. So IAS value, just the IAS value independently. Delete. And then we want heading. So now we're going to go to heading value. Delete that. And again, instead of the data value, we want to be updating our dedicated course value. And as far as our transponder code is concerned, we're already updating this one, but sure, we can go ahead and say, let's delete that condition. And there has to be a condition, so we're going to add a condition. And we're going to go look for transponder code 1. And we'll do the same thing. Transponder code 1 is greater than -1. Then we're going to go ahead and we're going to change our individual transponder code that we've got, and it will update to that. Next up, we're going to go to our AP modes. Now this is the one where for each one of these annunciators, we wanted to treat them like a normal LED or annunciation. So again, we're running scripts for all of them, and we just went in and we threw down a whole bunch to drive that data. So Autopilot master, when it's 0, set the simple Autopilot mode annunciator to 0 as well. Copy, paste, right? Copy, paste, now 1, 1. Flight director 0, 0. 1, 1. Now, we could have done this by doing a simple if not -1, but this works. On these data value changes, it's automatically updating. So we did a 0 and a 1 for each flight director mode, heading mode, nav mode, altitude mode, IAS mode, vertical speed mode. So again, when we're on VS, we can click on VS and it will get our vertical speed mode. We've got our approach mode and we have our reverse modes. So this is using the script panel. And now when we go to a different plane, for example, so let's use the profile switch, head over to the CJ4. When we come back to our script panel, you're going to see that here, right? Autopilot altitude lock VAR 1, because this uses a different variable, right? It doesn't use the normal SimConnect. This is using the Microsoft Flight Sim VAR 1. So the added SimConnect values that expanded. So beyond the standard one. So it's got different ones. So we just came in and we mapped those appropriately for our modes and our data. So we just did all those the same, worked perfect. And now for our autopilot modes, Autopilot master used the same variable, right? The flight director used the same variables, but all of the other modes, heading mode, nav mode, altitude hold, flight level change, VS, those were all using the new LVARs that the CJ4, the working title guys, added into the sim. So we had to change those out from regular VARs to LVARs. So in that case, that was simply going to LVAR, right? Coming down to working title, and you can see that the CJ4, some of them show up. Some of them get filtered here somehow. I found for a bunch, I had to just stay on LVAR and scroll down to the bottom and get them that way. I have found with some of the LVAR stuff, not everything actually sorts into these groups that were created. I think it's just based on when the data was added. But whatever, not a big deal. Highlight LVAR, you would find those additional values. Same thing will get applied when you start working with LVARs for the CRJ. There's going to be all kinds of CRJ LVARs that you're going to have to work with. This is why we're doing this two-step mapping. It allows us to never change the firmware on our autopilot, and we can make it work with any autopilot that we want from any plane, whether it's default, working title, whether it's CRJ, doesn't matter. Fly-by-wire, everybody's that has to use separate values or different data, we can remap them. And so we're going to want to go ahead and publish this. We want to make sure we're the complete device, and we're going to do it for all aircrafts again, because now we can go into our 172 profile and just bring this back in. So we're going to click submit. So it's gone and it's published it. If I load up my own profile, I want access to these after I built my unit. I'm just going to hop into the G1000 because that's what we used. I'm going to go to that script panel, right? This one had my old call out panel with the old way of mapping it. So let's just click on a button. We're going to go to online snippets. We're going to go to the script panel, complete device, and here is our script panel. Ironically, I published 2 of them. I have no idea which one it is. So let's click on the top one first. And yes, replace all things. So no, we want the bottom one. Script panel, complete device. Let's try the bottom one. And that's the correct one. So we're going to go to, I'm going to intentionally up the value so that you guys find the correct one, because I can't, unfortunately, delete existing ones. So, or even update it and modify it. So let's just grab it a couple times. All right, there we go. So let's get set up like we're going to do the ILS 07. So we're going to take off from 04. We'll make left traffic and come around to do the ILS into 07. Use what we normally get as GA planes doing a practice approach. We'll use 2000, and that'll allow us to come in a little bit lower and a little bit sooner and capture that glide slope from below. Then I'm going to go to our heading mode, and we're going to move our heading bug. And so we can see right now we've got our heading bug matching our current heading. Perfect. So currently our flight director's on. So our flight director, we've got our command bars. If we were to hit the toga button, it's going to give us the pitch up, obviously. So right now it's got roll and pitch. So let's get going. Whoa, what is that guy doing? All right, well, luckily we got off. All right. And we're going to go ahead and get rid of our flaps.
Positive rate.
We're going to go into heading mode. And we're going to go into IAS mode. And let's go ahead and climb with 95. And we'll engage the autopilot. So now we're flying by autopilot. We'll go back into heading mode. And we'll go straight into the downwind. And now, of course, on nav 1, we need to get ourselves IOW, so 109.5. And we've got IOW. And so here we see autopilot, flight director, heading, and IAS has gone out because altitude has captured. We've now seen that the glide slope has moved above us. So in heading mode, we're going to go ahead. Let's fly a course of, or a heading of 130. To intercept the localizer. Alright, so 130, waiting for the loc to come alive. It comes alive, so we enable nav mode, and we let the autopilot intercept, and we enable approach mode. So approach mode, altitude, and it has captured the glide path. So let's go ahead, start backing up. We blew through. I should have had a sharper intercept angle to start, but whatever. Point was to show. It will do it. All right, so now we're on approach mode, autopilot, flight director, right? So our heading, we can go ahead now and prep our heading. So we're going to fly runway heading for the mist. We've got that in there. And then we can go ahead, and mist approach altitude is up to 4,000. So we've now got our data in for our heading to fly, our approach to fly, and we've got ourselves on the glide path, flying our 90 knots. All right. Well, I think you guys stuck with it long enough. You wanted to see how it all turned out. That's how we did it. That's how we went from A to Z, got everything built, got everything into the sim, and got ourselves our own autopilot from a 3D Arduino. It's pretty cool, pretty easy to do, and it's pretty low cost. So anyway, as always, hit that like button. Subscribe if you haven't. Come along on the next one. Don't know what we'll be doing, but it'll be something sim related as we still wait for MTT. Have a great day.